access and energy. Number 2, computing power. Number 3, data access. Number 4, talent building. And number 5, credible, responsible AI framework and policy. Among those 5, everything is very important, but we are currently struggling with some lack of access to computing power and data sets. So that's why today's discussion is very important. Unfortunately, more than 80% of our data set in the world are very heavily skewed to the developed world, high-income countries. Less than 2% in Africa, sub-Saharan Africa. If we just carve out South Africa, less than 0-something%, only for the other sub-Saharan Africas. So we see the big gap in these spaces. So this is pretty important time to talk about how we can really democratize the computing power access in this space. So thank you for joining us. And then I look forward to really good discussion with all of our panels. Thank you.
Thank you, Sangbu, for that opening. So I will start by asking the panelists to introduce themselves in a very short way, and I'll start with myself. I'm Faith Waidaka. I build the infrastructure that makes AI possible. So I build the electrical, mechanical infrastructure in data centers in Africa, and I'm also the board chair of the Africa Data Center Association. So we'll go this way. Yann, please tell us who you are.
So I'm Yann Lequin. I'm the executive chairman of AMI Labs, Advanced Machine Intelligence Labs, which is a new company I'm building to build the next generation AI system. I'm also a professor at New York University still, and I'm just a month ago, I left my position as chief AI scientist of Meta after 12 years at Meta.
I'm Sanjay Jain. I lead the digital public infrastructure team at the Gates Foundation.
I'm Saurabh Garg. I'm secretary in the Ministry of Statistics and Program Implementation in the Government of India.
And I am Chennai Chair, the director of Masakane African Languages Hub, which emerged from a grassroots community called Masakane, focusing on African language NLP.
Good. So, Chennai, and coming back this way to all my panelists, what is the single biggest barrier? And I can imagine that we're all coming from different segments from the introductions we just did. But what do we feel is the single biggest barrier today to democratizing AI compute? Chennai?
Thanks, Faith. So there are over 2,000 documented languages on the African continent. So our single biggest barrier is the breadth of work we actually have to do to document these languages, to ensure they're well represented, and also focus on the communities that actually speak them.
I would say access to models, open models, and AI literacy to be able to utilize those models. And the reason I say that is perhaps infrastructure is something which might get acquired over time, and hopefully the requirement of the size of that infrastructure may also change. And the focus, we probably need to focus much more on the models.
I would say too much concentration of digitized data only for developed world.
Actually, also go on the data point, because we believe that AI will scale effectively only when data for everyone is available. So when I can get a personalized service because my personal data is accessible through some protected means to a model, so then that will allow AI to reach everyone.
I'll just echo some of the things that were said earlier. Certainly, the availability of top-performing open models, open weight, but also open source, would be a way to remove the barriers or at least, if not a sufficient condition, at least a necessary condition. And the problem is that today, there is no such thing. The open models are behind. But there is a way to get them to surpass the proprietary system, and it's through data. So the access to data was mentioned. If various regions of the world collect or digitize their cultural data, whatever it is, and then contribute to training a global model that would constitute eventually a repository of all human knowledge, then those models would be much better quality than other proprietary system, because the proprietary system would not have access to that data. And this can be done technically in a way in which regions don't need to actually communicate that data. They can keep ownership of that data and then contribute to training a global model by exchanging parameter vectors. Don't want to get into the weeds of technicalities there, but it's a form of federated learning, and I think this is the way to open up access to AI, and it's absolutely crucial for the future, because we're going to need a wide diversity of AI assistants, for the reason that there's a wide diversity of linguistic, cultural differences, value systems, political opinions and philosophies. And if our AI assistants come from a handful of companies on the west coast of the US or China, we're in big trouble. So we absolutely need this.
Okay, so we've had the challenges, and there are a wide range of them, from inclusion to compute to data sets. What we're going to discuss today is how do we overcome those barriers from the different perspectives and the different angles that we have on this team. So coming to you, Sangbo, from a World Bank perspective, what does it mean to democratize AI? And would you please give us one indicator that signals that a country is moving from consuming AI to actually building it?
From the World Bank point of view, democratizing data computing is very important. But let's think about this. So many people are very easily talk about building data center itself physically, and securing more GPUs and servers from the beginning. I agree the fundamental infrastructure is very crucial and very important, but more important thing is that how can we use that computing power for what? So we need to really think about what would be the best way which can create demand for computing power. That is more crucial part. So without having very clear application and some solutions, nobody can really run their own computing data center business in Africa. So it is a very crucial part. So I would like to say we need to think differently from, even though computing power is very important, how can we really create the data demand? So in this regard, so the clear indicator is that how can we really fully manage the data in the local. So one good news is that anyhow, local data, local context can be fully owned, controlled, managed by local country and local people. So that is a very good news. Even though we see a lot of inequality in the computing infrastructure and resources, but what cannot change even in this AI era is that people and the local country and local community can strongly hold their context and then hold their data set. So it is really important signal and opportunity. So I would say, measuring the fully utilizing and harnessing the data set in the local will be the key indicator for this.
Okay. Jan, you spoke about compute a few minutes ago, open compute. And I would really like to know, is the concentration of frontier compute a temporary scaling phase or a structural feature of AI? And where do you see the biggest technical opportunity to reduce compute intensity? It's something that Sangbu as well touched on.
Okay, so first of all, I think the computing requirements for training modern AI systems is temporary. It's temporary because the type of AI systems that we build at the moment, LLMs, essentially are knowledge storage systems, right? They accumulate factual knowledge, and therefore they need enormous amounts of memory. The reason why the models are so big in terms of number of parameters, we're talking hundreds of billions of parameters, which make them really expensive to train and to run, is the fact that they just accumulate knowledge so that it can be easily retrieved. But there's another way to be useful in terms of AI. It's not accumulating knowledge, but actually being smart, okay? And you can replace knowledge by intelligence. So current systems are not particularly intelligent, but they store knowledge. There is another revolution of AI coming, which actually my new company is built around, which intends to build systems that are smarter, even if they don't necessarily accumulate as much knowledge. So those models will be smaller. Now, the bad news with this is that perhaps at inference time they will be more expensive because they'll reason more than current systems. So we're going to see maybe a shift in the requirements for training, but the requirements for inference, which is really where most of the computation goes, is still going to be quite significant. Now, to answer your second question, the incentives are there for the industry to reduce the power consumption of AI system. A lot of engineers working on AI in industry these days, even in academia, are actually focusing on how can I make this model smaller, how can I distill it in a smaller model, how can I use mixture of experts so I have sort of a ladder of models that are more and more complex, so that to answer simple questions I can use a simple model, etc. All of it is to optimize power consumption. Why? Because that's where the money goes. That's where you spend all the money when you operate an AI system. It goes into power and maintaining your hardware. So the incentives are there. So that's the good news. You don't need to have laws or regulations or anything. They are working on it because they need to. The bad news is that it's progressing as fast as it can, and it's not fast enough. Okay, but we're not going to be able to make it faster unless we find some technological breakthrough at the fabrication level or the architecture or technology. There's a lot of mileage to be had in those things still. The power efficiency is actually making progress really quickly, much faster than Moore's law, and but it's still too slow. So I'm not expecting like some big revolution in hardware design until we start building something else than transistors on CMOS transistors on silicon. That's not happening for another 10 or 20 years.
10 or 20 years.
Well, I mean, there's going to be progress, in the meantime. It's not what I mean. But but if you want like a real breakthrough, like some completely new way of building computing systems, there's nothing on the visible horizon that really will allow this, whether it's carbon nanotube or spintronics or whatever it is.
Okay, that's very interesting. To think that the training models will become smaller, yet the inference might be the one that will take up the compute. Yet we're also looking at bringing inference to devices as close as possible to the people using it. So there's a bit of a balance to be done in that 10-year period. I think 10 years is a lot of time considering what AI has shown us over the past decade. And I think in terms of research, we might see it sooner. Yeah, Sarab, You led the other digital ID, and now in statistics. How do you see digital public infrastructure enabling AI innovation? And how can countries expand access to shared AI infrastructure without creating new dependencies or compromising data sovereignty?
Thank you. So I think two characteristics of digital public infrastructure which are key are to ensure that not only there is access, but also agency of the people. So most people would not like to be just consumers, but also be co-creators. And I think that's the real issue going forward. For any system to be a DPI, I think there are a few essential characteristics. It needs to be trusted, it needs to be interoperable, and shareable. And obviously, reusable is part of it, because, and that's what Aadhaar is. It's able to bring these characteristics onto this. And this is what will also ensure that innovators focus on solutions rather than trying to get together the infrastructure together. And in the Democratizing AI working group, which was one of the 7 working groups of this AI summit setup, which I had the privilege of chairing along with representatives from Kenya and Egypt. One of the outcomes of this, of course, there was a charter on AI diffusion, but one of the outcomes of that is what we are suggesting building initially, which might be a digital public good, but modularly it will become an infrastructure as we move ahead, is the Maitri platform, which we've called Friendship. And Maitri standing for multi-stakeholder AI for a trusted and resilient infrastructure. And how we can, in a modular manner, add on the 4, which I think my fellow panelists have also mentioned, components of AI: compute, data, models, and talent. These are the 4 aspects, and of course, governance mechanisms would of course be there. So how we can ensure that different countries are able to contribute in whatever manner to build this, if I can call it a global platform, which is in a way owned by all, and yet looks at what are the issues of real criticality. And I'm sure there's a major role for not only countries, for private sector and philanthropies to be able to build this structure together, which will meet the requirements of countries, private sector, and the philanthropies, because each of them have different motivations to it, and the private sector would have a profit motive, and that has to be kept in view. As far as the dependencies, that's the second part of the question that you asked me. I think one of the areas is that we need to ensure that we follow a federated structure rather than a centralized structure. I think that would be key because, and that will also ensure that the variety of languages and cultural contexts that the data sets carry, and which will also ensure that ownership remains where whoever has contributed with the data. And yet technology and open systems exist now to be able to ensure that that sharing can be done in a safe and trusted manner. So how we are able to ensure that this collaboration and cooperation is done based on trust, and what kind of mechanisms we can develop. And they could be partly technological and partly policy based or protocol based. And a combination of this will ensure that we don't generate new dependencies.
Thank you. Sanjay, when I said DPI, you nodded your head. So in terms of digital public infrastructure, we've seen it scale because it was interoperable. How can we ensure that data and AI systems that we build now are interoperable and open by design, so that even small startups or governments, like we've just spoken about, can plug in and benefit?
I actually want to go off what Dr. Gerg said. Broadly, DPI provides a way for data of all individuals, so their records, their ID, their transactions, are sort of the system of record on top of which DPI sits. So DPI provides a management layer on that and provides consented access. And so that's something which we have seen around the world, that particularly, like for example, in India, we see this a lot, is that now that you have access to all of this data, you can actually build on top of that through consented access, lots of applications. And that's really where a lot of the value comes in. And I think Jan mentioned about training data sets. Again, the same model can be applied to allow either consented access or anonymized access, so that you can do a federated learning so that the data never goes to the model, but the model comes to the data. And so and India has been looking at this data empowerment and protection architecture, which is on that lines. And that, I think we are now starting to see the structural building blocks come together, which would allow for this underlying data layer to be built, but that requires strong DPI. And so we do think that there's a lot of reason for countries around the world to adopt DPI systems so that citizens' data can be managed in a very trusted way, accessed with consent. And then we have things like MCP coming up, which then allow the user's context to be taken, which then allows AI to be safe. Of course, as long as the data is, the rights on the data are quite clear that they're not going to be stored. So overall, I think we are moving towards this world where we are seeing the underlying pieces come together. They have to come together at a global scale. I think that's the point that Dr. Gerg was making. And so from that perspective, I think we are in a fairly good place. But then to make sure this happens, we have to, I think, act in a unified manner. I mean, for example, we have to work together to fund efforts which are at the grassroots. So for example, what we are seeing with Masakhane, where you're working with countries, with communities, so that their languages can be represented. So that that context becomes very important, because finally we are going to have to serve users in their languages. So I do think, I'm very positive that we're moving in the right direction. I just think that there's still some ways to go. I think the other barriers as well. But on this aspect, I think DPI provides a way for us to get past the data hurdle, as long as, of course, DPI is implemented in a responsible manner in the countries and in the right way.
Thank you. Chennai. You've cautioned against technology becoming extractive. How should we build data infrastructure that is trusted by communities? And would you please give us an example of what principles would make an AI project in a village or in a community, in some rural place in Africa, for example, feel empowering rather than extractive?
Thank you so much, Faith, for that question. And I think I have the pleasure of sitting here as a representation of what it means when community is involved in building something. Masakhane basically means we build together, loosely translated in isiZulu. And that was then a creation of a participatory approach in knowledge building as a result of being excluded in spaces. So if we're going to build data infrastructure that community trusts, is to respond to the realities that they live in and to be participatory. So that's the first example. And just to prove how important for something to be participatory is that 2019, 2020, there were not as many data sets around African languages. I think a source of data was the Jehovah's Witness 300 Bible. And they had translated the languages for their own purpose, which is fine. And then so the community came together, the Masakhane community came together and brought in everyone, linguists, NLP people, machine learning people, anyone who spoke the language, to actually develop the scripts and do the machine translation work on top of that. And this community that was unfunded, doing everything by the bootstraps, actually won a Wikimedia Award in 2021 for their participatory action work. And I think that is then crucial to actually show that if you're going to build trust, people have to see what the end value is and also be recognized. So this paper actually has, I think, about 20 people on it, a lot of people on it, which some people could never have been authors, but they contributed to it, and they've got a paper published, and that's significant. And then secondly, it's really thinking about meeting communities where they are, regardless of what their location is. It's realizing the inequity that we exist with. So one of the projects that we will be doing at Masakane is called Project Echo. It's designed to be a gender responsive project because gender transformative is also the North Star that we're hoping to get to one day. And in that instance, it understands the realities of gendered inequality on the African continent, regardless of any technological innovation. And what we're doing in partnership with Gates Foundation, and also working with IDRC, who are working on this as well as a gendered intervention, is to actually then work with tech entrepreneurs developing gender responsive use cases that focus on women's economic empowerment as well as health, to then think about how are we creating an impactful tool when you add African languages on top that will result in better economic outputs for them or better information when it comes to health. So again, it is thinking about designing with the communities and meeting them where they are. And then lastly, this is to say that we love to say this on our team, that what we're not doing is new. The technology may be new, but there are practices that we can borrow from other spaces to actually then ensure this is done. So I would like to reference the community network models. Last mile connectivity is a significant issue across the continent. We've had universal service access funds as an incentive for mobile network operators to do this, but sometimes some communities are not served well enough. And so then there has been interventions to actually result in internet connectivity that's localized, being developed by the communities. They're in charge of building the masts for their community networks. They're in charge of creating the content that people are going to need, figuring out what the necessary power is. Do you then have a transformative booster in one person's home, and then people go and charge their phones there, because it's the whole life cycle of this. So if we're going to build infrastructure that people trust, we have to borrow from what's already been done, and then ensure that people are part of the whole life cycle so that they see ownership, and also it allows for sustainability because they are like, that's my resource. And I'm not going to wait for anyone else to support it, but I am going to be in charge of making sure that it continues to exist.
Interesting. I like that, community ownership. And I don't think we can do that if we don't build small AI. So Sangbu, you've written a lot on small AI. What would be your playbook for scaling small AI responsibly?
So let me introduce what small AI is. Small AI is not really small, but in this very, big tech-oriented, big scale of large language model point of view, it is, some small but practical approach. So the small AI is very practical and affordable and locally reliable and relevant model. So sometimes it doesn't require very heavy data set. It doesn't require any very high-end smartphone capability. Also, it can fully lean on local language. So that is small AI. So why small AI is very important? Because without clear, applications and use cases which can provide more value to our people, we cannot fully harnessing this technology only with infrastructure. So we are just do some reverse engineering and cultivating the demand first rather than providing some infrastructure. So this is the new approach. How can we really create some aggregated demand which can scale up throughout so many people, throughout the multiple countries, and for whole developing world. So this is our main approach for small AI. Why small AI need? Why do we need that? Actually, let's look back the 20, 30 years ago when computer innovation started and mobile innovation started around 15 years ago. What I have observed in that era it was still supplier and developer and engineer oriented service provisioning in some sense. The human customer and users were not in the center because there's so many restrictions. User can restrictions, so user cannot fully utilize some technology without get trained and learn. So 20, 30 years ago, we talked a lot about digital literacy and some basic digital skill and how to use Windows and Explorer, etc. That meant it is not very user-centric because user had to do a lot of things. But now, AI is going toward very user-centric services. So users doesn't need to do that much. They can only control and ask verbally about what they are curious, what they need. And then it can be automatically provided to the users. That is the philosophical concept of AI in my mind. So in that sense, our focus is how to bring more user-centric mindset to this field along with our client, because we have, compared to developed world, we have pretty much big context-based ground and local data and so many user interests. So that's our approach. That's how we gonna fully harness and utilize for this AI.
Thank you for that. Now that we're speaking about communities and users, Sanjay, you've spoken about moving from digital aid to digital empowerment. In the context of AI, what would digital empowerment look like? And what should development partners like Gates, World Bank sitting in this forum prioritize so that countries are not just consumers of AI, but co-creators?
So the thread I'm going to pick up back is the DPI thread. And broadly, what we have done in that space is to look at how, instead of building systems for countries, we sort of have open source systems which countries can then adopt to build systems which are adapted to their needs. So when we look at Aadhaar in India, that's one thing, but then for the rest of the world, we're looking at MOSIP. And MOSIP is a modular open source ID platform that we have supported, which countries are taking and building with their own policy layers, building their own application versions of it. And so in Ethiopia, you have FIDA, which is based on MOSIP, and it's actually very much customized to what they need. So the idea is you build these pieces of technology which then countries can adopt and build in a way that suits their needs, is governed by them, is local laws work on that. So all of that institutional infrastructure, legal infrastructure, is then sits on top of the technology layer to do that. Similarly, we have supported other open source efforts like OpenG2P for government payments. We have supported Digit for healthcare campaigns. And so the whole idea is you build open source, let countries and communities take that and adopt it. Similarly, with Masakhane, again, the same idea is that if you have a way by which local communities can come together and collect data, but then make that available for global needs. So we have funded those kinds of efforts in India and in Africa as well, so that these efforts are now there where local communities are empowered to make sure that AI systems can understand and speak their language. And that is, again, a form of empowerment. So broadly, that's sort of the way we think about it, is how do we build open standards, open source products that countries and communities can use and contribute back to, and co-create essentially their versions of their systems that then work in a unified way across the world. And so that is really empowering them to be a part of the community, and that is what we would love to see more happen.
Thank you for that. Now, Jan, I can't help but come back to these world models that, in my mind, I was thinking they would increase the compute power necessary, so the infrastructure would be bigger. But from your explanation, it looks like being more intelligent means less compute, And we now move the power not on the grid side for the training models, but on the inference side, on the devices. So what does that actually mean for the government people, the AI ecosystem, the startups that are in this room? What should be their focus over the next 1, 5, 10 years if these changes are to happen? And I do believe they will happen.
Wonderful question. Thank you. So there's going to be another AI revolution, right? We've seen in recent years the deep learning revolution and the LLM revolution. And unfortunately, the type of AI systems we have access to at the moment manipulate language very well, and it fools a lot of people into thinking that we have it made, that we have systems that are as intelligent as humans because we think of language abilities as properly human. But it's a mistake that generations after generations of computer scientists and people around them have made in AI for the last 70 years of discovering a new paradigm for AI and assuming that this paradigm will lead us to systems that have human-level intelligence. And it's just false, and it's false today as well. Our current technology is limited. It's useful, there's no question it's useful. It should be deployed, developed, it's going to help people. I use it all the time, but it's limited, like previous generations of computer technologies and AI systems. So what is the next revolution? It's the revolution of AI systems that understand the real world. And I think there is a lot of applications of that throughout the world for all kinds of all kinds of domains of market segments, if we're talking about commercial systems, or just helping people in their daily lives. Now, it turns out that, and we've known this for a long time, that understanding the real world is much, much more complicated than understanding language and manipulating language. It's because language is a sequence of discrete symbols, and it turns out that makes it easy for computers to handle. But the real world is messy, it's high-dimensional, it's continuous, it's noisy, and it's just much more complicated. So I've been making that joke for many years to kind of try to explain this to everyone, that your house cat is smarter than the biggest LLMs. And in many ways that's true. Certainly in the understanding of the physical world, your cat is way smarter than the biggest LLMs. Doesn't mean the LLMs cannot accumulate knowledge about the real world, but they don't really understand the underlying nature of it. So the next revolution are systems that really understand how the world works and sort of learn how the world works, a little bit like children who open their eyes. And let me give you an interesting number. LLMs are pre-trained today on basically all the text available on the internet publicly, which mostly is English or languages spoken in developed countries, which of course, as this panel has pointed out, is an issue. But it represents roughly 10 to the 14 bytes. Okay, a 1 with 14 zeros. That seems like a lot of data, and it is, because it would take us, any of us, about 500,000 years to read through it. But then compare this with the amount of data that gets to the visual cortex of a young child. In 4 years, a young child has been awake a total of 16,000 hours. And if we put a number on how much data gets to the visual cortex, it's about 2 megabytes per second. Do the arithmetics, that's about 10 to the 14 bytes in 4 years, instead of 500,000 years. And so it tells you we're never going to get to human-level intelligence or anything like that by just training on text, which is human-produced. We're going to have systems that understand the real world and are trained to understand the real world through sensory input. It can be video, it can be all kinds of stuff. And by the way, 16,000 hours of video is not a lot of video. It's about 30 minutes of YouTube uploads. Okay? If you get a day of YouTube uploads, it's about 1 million hours. And that's about 100 years of video. And we have video systems that we've trained, that have been trained with that kind of data. they understand a lot more about the real world than any LLM. They can tell you if something impossible happens in the video that they watch. So they've acquired a little bit of common sense. So my guess is that this is going to make a lot of progress in the future. And from those kind of techniques, we can build world models. What is a world model? Given an idea or representation of the state of the world at time t, and an action or intervention that you imagine taking, a world model will predict the state of the world at time t+1 resulting from this action or intervention. And this is how you can build intelligent systems, because they would be able to predict the consequences of their actions before taking the action. And they would be able to plan and reason, because reasoning is like planning. So everybody is talking about agentic systems in industry. The way agentic systems are built today is not this way. Agentic systems today are not able to predict the consequences of their actions. And this is a terrible way of planning actions. So I think, again, we're going to see a revolution over the next few years based on world models, based on systems that can learn from the real world, messy data. And I'm not very popular in Silicon Valley when I say this, but those are not generative models. They're kind of a different type. My colleagues who work on LLM and generative AI don't like me very much.
So for me, I'm really liking this. So I'm going to ask you a number question. What would it take? What kind of money would it take to make this faster?
Okay, so there is a number of different things that need to happen. The first thing is there's a lot of research to be done, like academic research, right? And in fact, what's interesting as a phenomenon is that this idea of world model and those non-generative architecture, which I call JEPA, but there's sort of various incarnations of it, are mostly worked on by academic groups who are interested in applying AI to science, and mostly ignored by industry. Industry, particularly Silicon Valley, which is the dominant players, is entirely focused on LLM, and everybody is working on the same thing. Everybody is stealing each other's engineers and working on the same thing because nobody can afford to do something slightly different and then run the risk of falling behind. And so that creates kind of a monoculture that makes the industry a little blind. And so right now it's in the hands of academia. So basically kind of propping up this kind of research in academia and preventing LLMs from sucking the oxygen out of every room it gets into, I think is the first step. Second step is, of course, there is a role for governments and industry to play there in sort of pushing those models once they work. And that's what I'm working on. That's why I left Meta and created this company, which is because I think the time is ripe for trying to make this real. And then obviously there's going to be a lot of applications of this everywhere in the world. There was an experiment that was run a couple of years ago, by some of my colleagues at Meta, where they gave smart glasses to farmers in India, rural India. And they could talk to the assistant in Indic languages, in the AI assistant, asking them, what's this disease on my crop? Or should I harvest now or wait a little bit? What's the weather tomorrow? So there's a lot of things like this that could be useful if the price could be brought down with systems that really understand the world better than we currently do. And in the future, all of us will be walking around with an AI assistant that will essentially amplify our own intelligence. It's like, all of us will be sort of, the leader, a manager of a staff of virtual people who are smarter than us, okay, which is a great thing to do, by the way, I'm very familiar with the concept of working with people who are smarter than you. It's the greatest thing that can happen to you. So, we shouldn't feel threatened by that. So it's going to, allow people to get more knowledgeable, more educated, make more rational choices. But we need systems that basically approach or surpass human intelligence in certain domains and understand the real world.
Thank you, Jan. So we know where Jan is putting his money. Coming back to all my panelists, not just your
It's
money.
actually
If I
other
gave
people,
you,
other
yes.
people's money.
If I had $500 million to give, and I'm not asking you for a P&L, I'm not asking you to give me a profit, I'm just asking you to help me democratize AI and make it accessible for everyone. Where would you each put your money? Let's start with Sanjay.
Incidentally, 500 million is the amount that you're looking at as raising capital to get DPI everywhere in the world, because we think that getting those underlying systems of record, getting people access to their data in a digital form, can actually empower them so much that they can then participate in the AI revolution in the right way with the right controls and structures in place. So you've kind of just made my case that we would want to think about how we can take that money, deploy it, and bring everyone up to the same level in terms of digital infrastructure, getting the data, getting the ledgers, getting the health records, all of those digitized so that then they can take benefit of AI for their needs. So that's actually what we would want to do.
Okay, Sangbu.
Again, I would say I would spend that big money to develop some more use cases again and again. So we are identifying agriculture, education, healthcare, and some more. The government service can be a really promising use case field. So developing some more practical and profitable use case, and which adds so much value, will be the really critical one. On top of that, maybe while we are developing the use cases, more important thing is that some change user mindset and inspire users. Because one typical problem we are facing is that our low-income users and clients and people do not really know what they don't know. So inspire, even though they can do something with this type of technology, but they don't clearly understand what they can do. So inspire them that they can really do this with higher productivity, with low cost. That will be very important, things to remind them.
Given the volume of funds available, I would focus a lot more on capability development of people to be the ability to use AI for improving productivity. And maybe if I can add to it, just to again stress on models, on the need for small domain-specific niche models. Small may not be the right word to use, but domain-specific and niche models, which will ensure that they use a lot less power, a lot less infrastructure, and not have the problems of large language models.
So I'm assuming each one of us is getting 500 million?
Yes.
So I co-sign on everything. In addition, I would say for us what is critical, given the point I mentioned about the breadth of work that needs to be done, is actually having open models and also investing in talent. So the open models do allow for people to innovate on top of them, and an example of this is Crane AI, which actually developed a offline first AI stack focusing on health education and agricultural services, and they emerged from the Masakane community. So what happens when we actually can fund a lot of people to think about this and build on top of open models? And then lastly, talent. Talent is very important across the whole value chain. Talent that actually looks at the building of the models, the uptake, the business cases to motivate for people to allow for sustainability, but also the talent to actually build capacity of the end users to understand, so that we create an ecosystem where people are excited for these new technological interventions instead of afraid. And that's sort of been the biggest narrative of you're either very excited or you're very afraid. And coming from a South African context, everyone is afraid to lose their job to AI. So how do we ensure that we're creating that ecosystem that's favorable for innovation?
So, as we come to the end of our panel, with everything that's been said, even with all the money on the table, free money, we see that it's not a one-size-fits-all. We simply can't just focus on one area and leave the rest. We need the talent, we need the compute, we need the data centers, we need the regulatory reforms, we need everything to come together to make this possible. And with that, I'm done with my questions. I have 5 minutes. If before I even finish my question, so would someone help me with a mic? What I'll do, I'll take 3 questions, hopefully to 3 different people from you guys, and then since I see no one, I'm quite good. Thank you. Let's start here.
Thanks, Faith. Thank you all for such a brilliant session. My name is Arun Sharma. I work with the World Bank. My question to anyone, Jan specifically, what is the lag that we have in the physical and the virtual world? It's dominated a lot by the machinery. I mean, you gave the example of a farmer wearing glasses. But then the seeds or the fertilizer, anything that he orders still run on archaic systems. So obviously there is a lag between the hardware and the software. The software is evolving much faster. Where do you see that happening and going? And I ask this specifically because in the Indian system, where we've not been able to deploy our resources is in the education space or in the healthcare space where we still lag in those areas. So thanks.
So, yeah, sorry, before you answer that, let me take the 3 questions. I would prefer that you throw the next question to someone else. I'll take the question from the back there. The guy with the specs. Yes.
Thanks a lot. Daniel Dobosch, particle physicist from CERN originally, and then now research director for Swisscom. You mentioned federated learning. Technologically, this is easy. The architecture of collaboration might be difficult for that. So do you have some ideas which kind of organization could coordinate this kind of collaboration? Thank you.
Okay, and one last question. Let me take it from here. The guy with the red tie.
Hi, thank you, Likun sir. My question is to you. Like you have said that we have the data like 10 to the power 14 bytes, and the same data that a boy consume, likely 4 to 5 years of age. So do you think that data is the only bottleneck, despite of compute and the architecture, to get the AGI, or maybe the humans, the superintelligence, artificial superintelligence? And the next question is, when we will achieve AGI, what was the benchmark? Like how we benchmark AGI that like it will be definitely smarter than humans. So how humans will evaluate that? So yeah, that's it.
So, yeah.
So quick answers. I'll go in reverse order. So there's no such thing as AGI. There is human level AI perhaps, but human intelligence is extremely specialized. And so calling this general intelligence is complete nonsense. Okay, but we will get to, we will build systems that are as intelligent as humans in all domains where humans are intelligent. It's just not going to be next year, unlike what some colleagues in the industry are claiming. This is going to take a lot longer. It's not going to be an event. It's not like we're going to discover one secret that's going to just unlock intelligence. It's going to be progress. It's going to be much more difficult than we think. It's always been more difficult than we thought in the past, and it's still the case. So no event for AGI and no AGI. Human level AI, yes. Super intelligent AI, yes. We should call it ASI, artificial superintelligence. Yeah, well, it depends. Okay, so that's the first thing. And you had a second part to your question. I can't remember what it was. So I'm going to answer the other one. There is a number of organizations that could. So first of all, the thing that's needed for this federated learning idea for an open source model should be bottom up. Like it should be people actually kind of, putting up a GitHub and then collaborating on sort of building the infrastructure for this. Of course, we can get help from governments and organizations, and that's required too. But I think it's going to ultimately people need to build code, write code. So there's a number of groups that have already built their own LLMs that are pretty good quality. There's a group in Switzerland centered at EPFL and ETH, Apertus, so you probably know it. There is a group in the UAE centered on MBZU AI. There is, similar models in Korea, in various other countries, and they all would like. I mean, they should all kind of, get together and basically join forces, and then, bring in other countries as well. I think SEM can play a role. I think UNESCO can play a role. I think. Switzerland should play a role, right? I mean, they have all those organizations in Geneva, right? Maybe that's where,
In Italy?
and the next summit is going to be there. So maybe that's the right thing to do, and have a bottom up and top down. One big organization that can play a role is the AI Alliance, which is a group that promotes open source AI.
Jan, let me cut you short. We've run out of time, and we would like to thank you all for coming. Yes.
Thank you so much for all the speakers. We just have a small memento from the government side to just make this a memorable event.